Okay, so today we are simplifying rational expressions. The world is a rational expression. It's just a fraction. Guys, literally today we are reducing fractions. Just like you reduce 2/4 to be 1/2. Just like you reduce 3/12 to be 1/4. It's the same idea. So, this whole thing really just means reducing fractions. Now, if you take a look at these, they're not quite as simple as 3/12, right? If I'm looking at some of these problems, they are mostly binomials on this page. We're eventually going to see some trinomials on the back. So, the way that we approach it is a little bit different, but it's the same kind of idea. So, I'm going to give you some rules. You have to follow these rules in order. If you follow them in order, you're going to be fine. You'll get them all right. If you follow them out of order, you will get them all wrong. So, here's the order, but it's super easy. Ready? Step 1. You are going to factor the numerator and denominator completely. Then you would leave it completely. And then step 2, you are going to cancel or reduce any possible terms. And I'll stress to you what are possible terms and what aren't. Any possible... Oh, no, let's not say terms. Let's say factors. Okay, that's really it. That's it. And then I guess you just write your answer, write what's left over neatly. Right? Answer neatly. So it's not a lot to remember. There's really only 2 steps. You just have to make sure that you do them in the right order. Okay? And I'm telling you, when we go to take our first quiz, someone's going to do it all out of order, and they're going to get everything wrong. If I look at number 1, I don't even look at the denominator yet. I just look at n minus 8. Is there anything for me to do there? Can I factor anything out? No. It's all fine. I'm going to leave it as n minus 8. In the denominator, I have 9n minus 72. I can take out a 9, right? They have that common factor of 9, so I will factor that out, and I'm left with n minus 8. Once I have factored it, I scribble the original one out. That's personal preference. I can't have so much that I'm looking at once. It gets so confusing. You just factored out a 9. They have a common factor of 9, right? Because 9 goes into both 9 and 72. So you factor out that 9, right? If I were to distribute it back in, I get right back to the original. So now I'm done with step 1. I have factored the numerator completely. There was nothing to do. And I factored the denominator completely. Now in step 2, I'm going to cancel or reduce any possible factors. Here's what I mean by that. See how I have an n minus 8 down here? Do you see that? Do you see this n minus 8? Is everybody looking? You paying attention? You watching? See how I have an identical n minus 8 right here? Yes. Those two, the whole bundle, can cancel with the whole bundle. What you cannot do, and this is, someone's going to do this, I guarantee you. I'm just going to sneak over to number 2 real quick. Someone is going to be like, oh, look, 9 over 27. I can reduce those. That is so wrong, I can't even tell you. Did they do step 1? No. They just hop right to step 2. You can't do that. You have to go through these steps. So step 1, I reduced an entire binomial with an exact same entire binomial. That's the only way to cancel out binomials. You have to have the exact same one on top, one on bottom. Now, I did say or reduce. So if I had, like, I don't know, pretend I had a 3 out in front. I could have reduced the 3 and the 9. But in this case, I didn't have that. So what's left in my numerator?
1.
Just a 1. If everything's canceled out, you just leave a 1 there. And then what's left in my denominator? Just a 9. That's my answer. That's it. That's all you have to do. Factor everybody. cancel everybody that you can, and then just write what's left over. That's it. You follow these steps and you're going to be all right. Yeah.
If on the bottom, like it's all canceled out, would you put 1 on the
You can, but you don't need it, because, like, you know, like 2 over 1 is just 2 anyway. All right, so let's try the second one. Is there anything for me to factor out of the top? No, so the top is already done. The bottom, what can you do, if anything? Take out a 3. Take out a 3, and then you'd have m minus 9. And then, is there anything that you could cancel? The m minus 9 with the m minus 9. So my final answer is 1/3. Let's make things a little more interesting now. Let's take a look at number 3. 7m from the top. Hold on. Okay, we just started here. I've left the worksheet on your desk. So we took out a 7m, and there's nothing left for me to do on the top, right? Is there anything for me to do on the bottom?
cancel it out.
Now I can cancel m minus 8 with m minus 8. So my answer is 7m, that's it. Let's try 4. What could I take out of the top on number 4? 7k. And I'd be left with 5k plus 1. Okay, this one's a little bit different. Is everybody watching this one?
Yeah.
So the numerator's done. Is there anything for me to do in the denominator? No. Step 1 is now complete. I have factored the numerator and the denominator completely. Now, I don't have a 5k plus 1 down here, right? So that's just going to stay. That's part of my answer. However, can I reduce these? Yeah, so I can reduce 7 over 49, and that would just be
7k squared.
1 over 7. But now look at your k's, too. I have k over k to the third.
K squared.
K squared where?
And the
Yes. So my final answer will be 5k plus 1 over 7k squared. Now listen, someone in this room, they're going to have this answer perfect. And then they are going to be foolish, and then they're going to be like, oh, look, I have a k up here and a k down here. I'm going to cancel them out. And I'm going to be like, what are you doing? You can't do that. Why? Why did I cancel these k's but not these k's? Miss Savia, this is so confusing. How am I supposed to know which k's I can do and which I can't? Well, rewind. Look at the 3 steps. Are you looking? Are you listening? Are you looking? Listening? 1, factor completely. 2, cancel them out. 3, write the answer. Did I say go back and cancel more stuff out? No, I didn't. If you've already done steps 1 and 2, you just write the answer. Why can't I? Because that k right there is part of a binomial. It's 5k plus 1. It's that whole thing. The only way I could cancel out any one of these pieces is if I had the exact same 5k plus 1 down here. You cannot cancel out a piece of a binomial with a monomial. So in other words, if I had something like 10k plus 3 over 5, can I cancel the 10 and the 5? No, you cannot cancel that 10 with that 5.
Oh wait, because it's not k.
It doesn't matter, even if that had a k on it. It doesn't matter. He is part of a binomial. In fact, guys, listen. If it's helpful to you to always put your binomials in parentheses, do it. And then you know, oh, I can only cancel that out if I have another 10k plus 3 down here. Then I can cancel those entire binomials. You cannot. Maybe let's put a big star. You cannot cancel a piece of a binomial with a monomial.
So if it's binomial over binomial, you can cancel?
Yes, and it has to be the exact same one. So if it's x plus 1 over x plus 1, sure, cancel it out. If it's x plus 1, 2x plus 1, you can't touch it. If you follow my steps, though, and you live by them and you do it correctly, you don't even have to worry about this. If you factor everything, cancel everything that you can, and then just write your answer, you're done. So let's try 5. All right, anything to do in the numerator? No, it's just a 12. But downstairs I can take out a 12. So then I'd have n plus 1. So now if I'm looking at my numerator and denominator, what can I do? Yes, these 12s can cancel because they're both, I don't know, single numbers. They're not part of binomial. So you and you, sure, you can cancel. So what's my final answer look like? 1 over n plus 1. Correct. Guys, the two people in the corner are talking, but the rest of you should not be. Oh. Any hoosers, I'm on 6. I don't know where the heck you all are. But 6. Let's see. Oh, my lid is falling apart. Here we go. 6. What do I do in the numerator? Nothing. Denominator. 20b. And what would be left? b plus 1, right? That's it. So now I'm looking.
Can you divide 90b and 20b? Or
You sure can. Because they are not part of binomials, right? So now these are loose numbers. You can't reduce them with each other. It's the b plus 1 that I can't touch unless I had another b plus 1 up top.
would it be 70 over b plus 1?
No. How do you reduce 90 over 20, the fraction?
Oh.
Yeah, if you have 90 over 20, don't you just cancel out the O's, right? So you really have 9 over 2? So I have 9 over 2 when I cancel the 90 and the 20.
Can you get rid of the b?
You sure can. B over B just cancels each other out. So my final answer should look like what?
9 over 2 parentheses b plus 1.
That's right. So I have just 9 on top, 2 on the bottom, and b plus 1. There's my answer. You just got to go one step at a time. If you go steps 1, 2, 3, easy peasy. Should we try a tougher one on the back? Yes, let's. And then we still have to go back and talk about, I don't know if you noticed in the instructions, but they are saying something about an excluded value. What even is that? I don't know. We're going to find out. Okay, let's start on one that doesn't look that bad. I was hoping, yeah, we'll just have to start on 11.
Can we do 15?
We'll get there. Let's start on 11. So, guys, listen, the steps are the same. Are you listening? Step 1, factor the numerator and denominator completely. So let's just look at the numerator.
Take 7 out.
You can take out a 7. So if I take out a 7, I have k squared plus 6k minus 7. I am not done yet, though, right? Because I can factor k squared plus 6k minus 7, right? Aren't there factors of negative 7 that add to be 6? Yeah, so that numerator, really, I'm going to have to write it over here. It really factors into 7 times, and then that would be k plus 7, k minus 1. Do you agree? So there is the numerator completely factored, right? You have to factor it completely. Now in the denominator, that one's a little bit easier. Factors a negative 35 that add up to be 2.
Negative 5 and 7.
Yep, a positive 7 and a negative 5. So, step 1 is now complete. Everybody agree? Numerator is completely factored, denominator is completely factored. It is only after I've done that. I did everything as far as I could. Now I'm going to cancel things out.
K plus 7.
Yes, I have a k plus 7 and the exact same thing on the bottom, k plus 7. Is there anything else I can do? No. So what's left is my answer. You don't have to multiply this through again. You can just leave it as 7 times k minus 1 over k minus 5. Is it wrong if you distribute that 7 in? No, but why bother? You don't have to.
Wait, why is it minus 5?
Yeah, so there's my answer. Yep.
Why'd you put the k minus 1 on top?
Because this one here factors again. Factors a negative 7 that add to be 6. We're positive 7 and negative 1.
I didn't see that there.
Yep. Okay, now, yes, let's jump to 15. So, on the top, what can I do? Take out a 10. So I'm left with x minus 4, right? In the denominator, what can I do? Take out 3x, correct. Is there anything else for me to do in the denominator?
You have to take negative 12 and get to a negative 1.
Yes, you have to keep factoring. If you can keep factoring, you keep going. Factors a negative 12 that adds to be negative 1, negative 4, and a positive 3. See how I told you factoring will never go away? I'm not kidding. All right, so now you're here.
Cancel out the x minus 4.
X minus 4s, right? I have the same exact binomial top and bottom. X minus 4 will cancel with x minus 4. Absolutely.
Can you divide 10 by 3 or no?
Well, no, because if it was like a 12 over 3, I would reduce them. But 10 over 3 doesn't reduce, so I just would leave it as 10 over 3. But if it was anything else that did reduce with each other, you absolutely would. So, is there anything else I can do? No, so that's my answer. What the heck is wrong with this pencil?
So you can like multiply it out if you want, but it's not.
I actually wouldn't. I mean, it's not wrong if you do, but don't. Just leave it. Let's jump to 19 real quick. Do you remember what in the world you're going to do for the numerator there? There's nothing to factor out of the whole thing. What did you say? Sorry.
No, that's the one where you like draw a line.
Yes. So, look at your numerator on 19. Is everybody looking at 19? Looking at the numerator? Everybody's looking? Sean, you're looking?
Yeah.
Oh, good. Okay. So, look. There are no common factors, right? There's not. I can't take a 9 out of the whole thing. I can't take an x out of the whole thing, right? So, Sarah mentioned combining like terms. She'd be right, but I don't have any, right? Because they're all different degrees.
No, my bad. I meant you have to do 2 separate equations for each half.
Perfect.
That's what I meant to say.
But I still like checking for common like terms, because if there are any, you got to put them together. So, she's right. This is where we're going to split them in half. Do you remember splitting them in half, factoring by grouping? So if you have 4, you draw the line right after that second one, and then you factor each side on its own. So what can I take out of x cubed plus x squared?
X squared.
And what would be left?
X plus 1.
X plus 1, right? And then on the right-hand side, what could I take out? Negative 9, and then what would be left? X plus 1. Remember how the parentheses were supposed to be identical? Right? They are, so that's good. So one of my factors is x plus 1, and the other is,
X squared minus 9.
yes, it's what's out in front, x squared minus 9. Okay, so now the numerator's factored, or is it?
So you have to go on. You have to do the x squared minus 9.
Yes,
X minus 3x plus.
perfect. That is the difference of two perfect squares. You're not done. Remember what step 1 said. Factor the completely. Completely. You are not done on number 19 until you realize, oh, that's a difference of two perfect squares. That's going to split again.
Keep the x plus 1, correct?
Yes. So this one's going to split into x plus 3, x minus 3. Now my numerator is completely factored. Now there's nothing else I can do. Downstairs, what can I do?
7x squared, x plus 3.
Take out a 7x squared, and I'm left with x plus 3, you say. I agree.
And then you take out the x plus 3 from the numerator.
Correct. I take out an x plus 3 with an x plus 3. By the way, guys, let's just pretend for 1 second that both of these were x plus 3s. You can still only cancel 1 and 1. So it has to be a pair. You take out pairs together. So you just can't cancel out all the x plus 3s. It's every pair. Yep. Sure. Is there anything else that I can do?
No.
No, there is nothing else for me to cancel, right?
X plus 1, x minus 3 over 7x squared.
You got it. X plus 1, x minus 3, all over 7x squared. Do you need to multiply that together? No! Leave it alone. There's your answer. Now, if you rewind back to the directions in the beginning, it has said, simplify each, we did that, but then it says, and state the excluded values. Do you have any idea what they mean when they say excluded values? Yes.
The one that we crossed out.
Not quite. It's a good guess, though. Lily?
The number not.
The excluded value is any value that would have given you a 0 in your denominator in the original.
Okay.
So, if I look at, go all the way back at number 1.
Boy.
Now, n can be any number in the whole wide world, right? Except if it makes my denominator become 0. So, once I factored it out, it's very easy to figure out what the excluded values are once you've factored it. What number would make my denominator turn into a 0? What number, if I plugged it in for n, would make my denominator a 0? 8, right? If I plugged in 8 for n, I'd get 8 minus 8, which is 0. 0 times 9 is 0. So that's my excluded value. So if they ever ask you, which they did here, excluded value, in this case, n cannot equal 8. If n is 8, that gives me a 0 in the denominator, and then that breaks the world, right? So look at number 3. What is m not allowed to be? 8. M could not be 8 here, so I don't know why it's 8's a lot, but whatever. Let's look at number 5. You always look at your factor before you cancel things out. What could n not be? -1, right. Again, the hang of this, see how if I plug in a -1, that would make it be 0. So what would it be for 2? M could not be 9. What about 4? 4 didn't have a binomial in the denominator.
4 can't be 0?
Exactly. K can't be 0 because then I would just get that 0 in the denominator. So no zeros there. And how about 6?
We had solved 6 there.
We did.
We did?
Mm-hmm.
Number 6?
Mm-hmm.
Oh, we did, I'm sorry.
-1 is right. There's another answer though. It's a little hard to see because we crossed it out. Remember there was a b? There was b over b?
Yeah.
And we cancel it out? So it also can't just be 0. So that's what excluded value means. That's how you determine it. So if we look at the ones on the back, so look at 11. When I factored it, it was here, right? So what could k not be? Can't be 5, and it also can't be -7, right? So -7 or +5. So those are my excluded values here. Okay? This is so I would not be surprised if there was a question like this on your final, right? That said, okay, simplify the rational expression. You did this, and you got this answer, and then it was also, and state the excluded values. So I bet you could probably narrow it down to two choices based on getting this answer right, but then if you don't know what they're talking about with excluded values, you'd be stuck between the last two. So just keep that in your mind. It's whatever is going to make the denominator be 0. So I can't have those ones. Okay, thoughts? Is this that bad? If you are good at factoring, you're going to be okay here. You just got to follow the steps in order. Factor, cancel, write your answer. All right.